My name is Brett Parrish, and today I'm going to explain my poster for my senior design project, Greenhouse Automation. The objective for the automated greenhouse project is to design an affordable, self-sustainable greenhouse which will produce proper growing conditions for the pepper plants. The greenhouse system will control the growing conditions, air temperature, soil temperature, humidity, lighting, soil water level for up to 6 plants. For the logic, Arduino boards are used for the logic of the system to activate outputs according to input readings. This is done by sending the output signal of the Arduino board to close the 120 volt AC relay contact for the outputs, which are going to be heaters, lights, humidifiers, fans, and heating pads. The biggest decision for this project was to choose the best option for logic, either using PLCs or Arduino. The PLC uses a ladder logic program, while the Arduino uses C++. But since we're trying to keep the cost down between $1,000 to $1,500, I chose to use the Arduino boards over the PLCs. Although the Arduino boards are more complex to work with, such as wiring and coding, they allow for more features that a PLC alone cannot do. For this project, I decided to use an Arduino Mega 2560. It is a microcontroller that uses C++ language to program inputs and outputs. I used it for this project because of the high number of inputs and outputs. This will eliminate having to use multiple Arduino boards and further complicate things. Some features of this board: the input voltage is 7 to 12 volts DC. It has 54 digital I/O pins and 16 analog input pins. Since this project will require turning on 120 volt power supplies, the Arduino board cannot do that. Max output signal is 5 volts DC. So in order to do this, I'll have to use relays. And the output signal of the Arduino will trigger the contact coil in the relay, closing the 120 volt circuit. This will turn on the heaters, lights, humidifiers, fans, and heating pads. In the picture below is an 8-channel relay. This is what I'll use for the design. It should cover all of the outputs needed. And to the picture of the right, the coil's energized as of then, so it is in a normally closed state. When the coil is unenergized, it will switch back to the normally opening of the 120 volt circuit. The picture below the relays is a flow chart of the whole systems diagram. On the left rectangles, you can see those are the sensors going into the input of the Arduino board. And on the right side comes out the outputs that signals the relays, the squares, which close the circuit for the 120 volt outputs, the circles. Alright, so what turns on the outputs? There will be sensors in the greenhouse taking constant measurements, regulating whether the data is over or under a certain threshold. In the greenhouse, the humidity will stay between 80% and 90%. The air temperature will stay between 70 degrees Fahrenheit and 90 degrees Fahrenheit. The soil temperature will stay between 60 degrees Fahrenheit and 75 degrees Fahrenheit. The soil water level will keep it between 25% and 40%, because we don't want the soil to be too dry, but we also don't want it to be too wet. The misting water level in the misting station, we want it over 25%, but less than 90, so you don't have to worry about overfills or spills. The storage water container, as long as it's over 25%, everything is good. In the chart below it shows the condition, the input, and the output. So when the humidity is over 80% or less than 80%, the humidifier will come on. But when the humidity is greater than 90%, the fans will turn on. When the air temperature is below 70 degrees Fahrenheit, the heater comes on to heat up the greenhouse. And when the air temperature is greater than 90, the heater will go off. For the soil temperature, the heating pads will turn on if it drops below 60 degrees Fahrenheit, and the heating pad cuts off when it's over 75 degrees. For the soil water level, if it's over 25%, the misters come on, and once it goes over 40, the misters shut off. For the misting station level, if it goes below 25% in the tub, the water pump turns on and pumps water from the storage station to the misting station. When the misting station tub is full or over 90%, the pump will cut off. Some capabilities of the automated greenhouse. Using an Arduino Ethernet shield, the system will be connected to the internet and will have the ability to send phone alerts to the user if maximum thresholds are exceeded. For example, if the ultrasonic sensor in the water storage station drops below 25%, an alert will be sent to the user's phone saying add more water. This is demonstrated in the picture below it on the right. Another example, since the heat needs to stay between 70 and 90 degrees, if the temperature drops below the max low temperature threshold 65 degrees or higher than the max high temperature threshold 95 degrees, an alert will be sent to check on the system. By doing this, this allows for immediate action to either shut the system down remotely, since it will be connected over internet, or go check on the system to see if there's any physical malfunctions. The systems of the automated greenhouse. The automated greenhouse design will consist of 3 sub-level systems: the control panel, the greenhouse, and the watering station. The control panel has 2 parts, the inside and the outside. The inside of the control panel will contain the logic that controls the whole system. This is the Arduino board, the Ethernet shield, terminals, relays, wire duct. This is shown in the picture below. For the outside control panel will display current measurements and LEDs to show the indication of the outputs. So for example, if the heaters are on, the heater indicator LED will be lit. Also on the front of the control panel will be an emergency stop button. This will shut the whole system down if an emergency occurs. The picture below shows the layout of the front of the control panel. The second sub-level system, the greenhouse. This is where all the sensors and outputs will be located. The humidity sensor, which indicates the humidifier or the fans. The soil temperature probe activates the heating pads. The soil water sensor activates the mister pump to water the soil, and the air temperature, which indicates the heater. The picture below is a full layout of the whole system. The third sub-level system is the watering station. This is separate from the greenhouse and the control panel. This is where the water is collected from the rain gutters into a 55-gallon bin. From here it is pumped to the misting station when the water level is low in the misting station. The water station consists of water storage, the rain barrel, the misting barrel, 2 ultrasonic sensors, and 2 water pumps. In the picture below shows the rain going into the storage from the rain gutter, the water getting pumped to the misting station, and the misting station pumping to the misters. Planned implementation. For the next semester, code will be written and tested. I'll do this by hooking the sensors up and hooking LEDs to the outputs to make sure they're activated when the sensor exceeds a certain threshold. After that, components will be mounted in the panel and terminated. The holes for the displays, which will be the measurement displays, the LED indicators, they will be cut out for the front of the screen. Last, the greenhouse will be constructed and cables will be ran to the control panel. Before powering up the full system, ohm meter tests make sure that everything is grounded and proper terminations are made. This will eliminate any health hazards with electrocution and so on. The last step will be to test the whole system. I'll just sit there and watch it and alter sensor readings to make sure that the corresponding output turns on when it should. The expected results of this project. In the end, the automated greenhouse will be able to control the air temperature, soil temperature, humidity, lighting, soil water level, all by itself. This will assure a high quality of plants are being produced with little to no effort.